Why is it not? Oh. Okay, I do. I get that. I don't even know whether I've got anything. Okay, have I now got sound? Have I now got sound? Okay, have I now got sound? Have I now got sound? Okay, have I now got sound? Have I now got sound? Okay, have I now got sound? Okay. Let's see. Do I have? All right, have I now got sound? Have I now got sound? Okay, let me go. Can you hear? Am I broadcasting anything now? Okay. Let's see. I have. Am I broadcasting anything now? Have I now got sound? Have I now got sound? Can you hear? Am I broadcasting anything now? I'm not broadcasting anything now. Because I'm not going to. Oh boy. Oh boy. Look, I think I'm going to proceed, at least for the moment, as if I'm, oh, I think I can chat. Let me chat from here. This still is, man, I think this is mediocre.
Fantastic. Can you hear me? Look, I think I'm going to proceed, at least for the moment, as if I'm, yeah, at least for the return to me. It's an incredibly long delay, but I think that still is. It's yeah. I think I'm going to go ahead and yeah, drop me a note. I have a separate screen here. There's no feedback. I obviously there's more to figure out on this. Man, I think this is something that attracts people to Forth is that things are so much more complicated than they need to be. In any case, I'm watching. I've got a screen looking at the demo. I guess actually my webcam isn't even tied in, but I think that I'm still watching the thing proceed, but it's real slow in moving on. It should move on to showing the cozy environment, but it's not moving at all. Oh, okay. There's I'm not seeing. Are you seeing? Are you seeing the cozy interface? I just am typing some crap on the screen, but the image that I'm seeing there, it finally went and caught up at least a little, but it's being way slow on if I look at the monitor that I've got monitoring. Let me. What would you? Oh, you already saw me type. So everything you're seeing, and I'm seeing your chat before I see the screen reflect what I'm doing. The monitor that I have separate from. But anyway, maybe what I should do first of all for this is to just start from the from if you've got it downloaded and so forth. Although I have some other videos. Yeah, this is the black background. This is actually. Let me just start the thing up from the file and then you'll see. Bye. And actually, I've got my own private one going too, but let me exit this and let me just come over to where this is and just start. I've downloaded from GitHub Forth Cozy, so and this is what you should see when you start up, although with the one change, not that I got by there. Normally, well, that's weird. Something has trashed the help that should have just shown up. I don't know what I work in this all the time, but the fundamentals of the environment, I have everything is lists. And so that's a hello world is a list, and got this is very APL-ish vocabulary. Reverse, for instance, goes and flips. The yeah don't the background here. Well, let me go move this over because this is what you're actually seeing. That's just the you know, MS-DOS window. But one of the things, notice this is a list. I mean, everything is a list. Boy, my screen is so slow. The only thing that's up to date at all is, you know, keeping up is chat. But row is the most fun. Oh, this is one of the things. I think maybe I'm going to sort of skip one of the things that Sam Falvo's comments made me realize. These are my notes from yesterday. I've scrolled all the way down in my notes because more than anything else, I mean, this is, if you will, an APL notebook. Uh, and one of the most important things is just, well, putting down, I had F12 for the day line. I don't know how I screwed up key help, but apparently that's, let me see. Where to begin, because there are other videos that have you know, introductory. I've gone through all of this before, but one of the things I'm going to go and just follow things and get into what the structure of the header is, which is something that Sam Falvo, and I also see with you having essentially your header being just the dimensions of the matrix. For the first, probably 15, 20 years of APL, all it had was rectangular matrices, n times m, m times n, although it had multidimensionals, so it had up to, you could even do up to perhaps 10 dimensions, which you run out of space unless it's like 2 to the 10th. But everything is in I'll just go and do it here. There's a root directory, which is a list. A row is one of the most fundamental sorts of okay, go back here. I'm going to assume you're seeing everything relatively close. So you're now seeing the fourth CoSy directory. I essentially downloaded from GitHub, which is a little behind what you're seeing on the screen here, but downloaded from GitHub. Let me start by going over to Coherent Systems page itself, and which has got links to a number of videos and all of that. I would assume that some of this you've seen. And then it gets into the stuff on physics down below. But going to GitHub, the branch, whoops, yeah, here's, I find the simplest thing, and I don't know whether you know GitHub better than I do. That's highly likely. Well, can you see the white window? I see. Well, the bottom line, and this is in videos. How can I, let's see, does this work? and expanding the text. I'm really, it's unbelievable how little I screw around with things. I think that there are other videos. I think that you can see this, but essentially the real thing is that I've gone to the GitHub branch and just downloaded the whole everything to a file, and then I if you see my you can't see the print on this. Let's see, how do I go on a view? Where do I options? Does that have it? Change folder? No. I don't even know. Small, well, list obviously, but Control Plus I would think would make things bigger, but it doesn't. Doesn't, I don't know. Shows how little I know even of Windows. I don't get out here much. Never really have a reason to change. I see that on my thing. In any case, if you go to GitHub and you see on there are other things, just download it and open it up into well, I've got it opened into this fourth CoSy directory, and once it's all unpacked and all of that, then fourth CoSy is you'll see that there's a shortcut that'll open it in a bat. But I'll once that's done, well, that'll start it, and you'll be in this environment here that you see. Except somewhere, one of the things that sort of is a problem is that since this is also my working, well, you'll see here are my notes. Can you read? The one thing that matters really is is the font on the CoSy window large to read? That's relatively large. Let's see. Can I browse? I can browse on GitHub. I just need to know. Oh, download the entire I can't follow the fourth CoSy link on GitHub web interface, huh? Is that an issue of the branch CoSy and just download? I mean, that's let's see. Yeah. One of the things is GitHub is another one of those things that I think is, does something that is extremely useful, but I think it's twice as complicated as it needs to be. And I think that it, I really, it's a better backup mechanism than what I have, which just does one backup and it keeps replacing that backup, and it's rather easy to overwrite your last backup with with a bad copy, and GitHub goes and does a much better backup. Let's see. Just need to know which file. It just go, and it's the entire directory. You just download the zip file, and let me go and I'll do that. And I just downloaded. Well, here's the time I downloaded it. Is this file right here? But just go and download it into a zip file, and then what I find is the best thing is to just create the file you want. How in the world? The view should say what the size of the stupid thing is. I don't see where, even in options. Why don't I see? I mean, I could change to icons, but I don't think I think icons suck too, and doesn't increase the size of the printing. Unbelievable that I don't even know how to change the size of the printing on a window thing. But in any case, the thing is that I just made a directory named Fourth Cozy, and then I copied all from that zip file. I copied all of the files in because Jesus, I can't believe it really sucks to not have why in the world can I view extra large detailed size content group by paste? How do I go in and properties? No, that's not going to do it. Anyway, just download the entire directory, and because the pieces of it, it's all built in Riva Fourth, and this contains a copy of Riva Fourth, and then all the actual code and like the source. Here's the Riva source. That's by Ron Aarons. Actually, is the person who's now got eighth. And there's a bin directory, but all of the CoSy code is actually in this CoSy directory, which I'm not sure that you can see but again, if you download it, you can see what all the files are and drop me an email or something. But let's see. Oh, okay. Oh, good. I see. I'm reading your comments here. Um, Legible. Okay, got the zip file. Oh, okay. Hey, this is actually makes good sense. I got together with what's his name, Dan, um, the robot guy, day after the fourth thing, and we did get CoSy going on one of his machines, and actually the path is this. I suggest you tell us what file you're looking at containing relative to the directory containing license. Let me, oh, that's the GitHub. What did I do with, yeah, I just unzipped all of I actually find it easiest to go and I made a directory Fourth Cozy. Yeah, I wish I knew how to make this bigger. But then I just took the entire zip file. Let me open that zip. New file explorer. When I downloaded it, yeah, here's the last zip. I open up the zip file, and actually it's then here's the entire actual zip file. I will make, and I hope that even though this is small, I then created this directory Fourth Cozy, and then I just went and essentially copied everything into the file. So I've got all of these. There are even examples and so forth. There's a library of various sorts of thing. All of these are Riva, the fourth, except for the CoSy directory. And that's where all of and I don't know that this is structured as well as it should be. Oh, gee, it's interesting. I can actually, it's legible on my It's slow but legible on my. Oh, it may be actually catching up. But the if it's are you looking at it in high res? Because you really should at 720. You should be able to read everything on the screen because it's just it's my screen to your screen. I suggest you tell file. Dan Golding, right. Don Golding. Right, yeah, we got it running on one of his machines. It wouldn't run under a something under Linux. I mean, he had a dual operating machine. It wouldn't run on that. But on his regular Windows machine, it ran without problem. I find it very interesting, useful feedback that going through simply getting the whole GitHub download and all of that is the first step. I sort of was planning on sort of sort of jumping into, okay, here it's running, so what can we do? Getting into the more conceptual aspects, like what the header is, because that's where I'm gonna let me go and pull up the browse through CoSy, and where's oh, here. Come back over here. There's so much in a sense to be there's. This is clicking the very top of the screen there. I get into this, but one of structural overview. This really needs to be updated, but it hasn't changed that much in about 7 years. Or in 2007, whenever this was. But this I think would be of interest to you. And this I can go and make bigger. Because this I noticed something that actually I think Sam didn't have an appreciation. Sam's video, if you watch that, because he really hit on some very, very important aspects. Oh, cozy.f is the main file. Just to show you what the nature, I'm now back over in CoSy, and one of the things is, first let me review. Got essentially 3 windows here, and this is little writing. It's res. This is the result window. Any results get put there, and this I call text. I think I may change the name to log, but I mean this you can see all of my work on things, including on most recently on the Pascal triangle. And then this bottom one, state, is static and essentially because, well, again, first comment in CoSy is if you type some stuff and just hit return, it just is like it's your notebook. But if you type something that is in fourth, like minus dot, no, this is where I can't believe that somehow let me see if that doesn't have enough. What about this one? No, that probably is the same. Somehow along the way, and I didn't know this, I wiped out the key help, and rather than, well, I could do some fancy things to get it off of another copy. But even going and writing a line to go and say, hey, grab something from another file is got to write a whole line. But let's see, what was I going to? Oh, yeah. Um, yeah, okay. Uh, this whole thing and some of the other things. Oh, I wrote this line of code of pure. Um, this is pure fourth. God, can't stand that I don't have the function keys. Actually, let me go and do something on my private thing, which I blew away. This is probably too small for you to see. It's sort of just as, whoops, I didn't mean to F6. This is what my basic help is. And I'm just going to cut and paste it over here. And actually, let me save that while I'm doing it. The result, whatever's in the result window, is res. I'm going to save it in a T0. But I wanted to get, okay, I'll fix that up later. But one of the things is now, can you see the help that I just brought up? Yeah, I know. One of the things is there are some cryptographic routines in the Riva source, and I've recently, one of my main uses, as a matter of fact, which I wouldn't show here, but I've got, this is again, I'm on stuff which is just as happy that it's too small, but I'm actually clicking, there's this ref window that I keep around, and that's got all my passwords and account numbers and all of that stuff in it. And if there's anything I go and need to lock up, it's the, but yeah, forget that. The one thing that, yeah, I I'm slowly learning to appreciate the need for security in the current day. I wanted to go and point out that, well, you've seen, I mean, if you just hit enter, whoops, it does nothing. If you click F6, it executes the line assuming a CoSy object. Shift F6 will execute it purely as fourth. So this is my favorite fourth example, 1, 2, minus dot. And now I'm hitting Shift F6 and you get -1. And actually, I think that if somebody knew nothing more about mathematics than that, that'd be rather confusing. It's sort of, what does that do? Take this glass symbol and stick it on front of the first one? But to go and write that same thing in CoSy, because CoSy is operating directly, those are right on the x86 stack, I have to make that an integer. Let me go and, something I find very convenient in reverse Polish. The bar is comment in this fourth, which I like a symmetric bar, but there, it turned that into a CoSy object. And so a list. So that is actually an integer list, and row is the most fundamental APL function. It tells how long. Good. Yeah, but actually that should work. So actually, and to go actually up to where we were before. Sorry, I tend to go around back to the hello world example. Hello world row. That's a list of 12 items. But that's the most fundamental thing. And actually, when you look at the structure here, matter of fact, let me go and dump, and that's at 6. Here's what that created. Here's what it took the 1 off of the stack. This first cell is type. And the next one, and for an integer that's 4, it's 4 bytes. But type is absolutely the first item that needs to be in the header, because in the sense, I mean, and it works, and essentially it's just available with a fetch. So any verb can go and decide, how to treat something by knowing its type. And then the second cell is the count, how many. So that, you see, is 1. Here. And let me go up and see the same thing. Let me go and bring this down, and you'll see the difference. Oh, and actually, I didn't realize that G-Forth also used F quote or S quote for, yeah, but if I do, by the way, I am creating some garbage, but here's the header on that. It's 1 byte. And that's the method that I've used, for characters. And then C, it's 12. So that's it in C. And then, well, it's bits per item, and I think this, I would probably change that and use the total thing. There are no reference counts on that. Let me go and do something. That's what's really important in making this entirely a dynamic system. But let me save that I've got some simple to use variables around, and execute that. Now, being T0, it's actually got a reference count of 1. T0 is referring to that. So it won't get, well, it's not garbage collected, it's just released. There's no moving around, at least with the K thing. Yeah, in Riva, that's just, matter of fact, one of the things that's a little on the small side, let me do, whoops. I'm shift F6ing this. I'm executing this in raw forth. You see down here, the stack is always shown. Whoops, why is it? Oh, I thought I could highlight that, but maybe you can see. I don't know what that. This is one of those things where I really, it caused. Oh, next time I do one of these, I will go and make the MS-DOS window bigger, more readable too. But I don't know exactly. It way for something, and actually that's a high priority thing to fix. But one of the things, every time you see we're back where we were. except whenever you do an F6, it actually goes and saves the entire environment, all the text and everything else, and it saves P0 and so forth. So, and every time you execute a line, you F6 a line, it actually is saving the entire environment. Let me go. Jesus, it's irritating not to be able to know how to these trivial things that never was important to me to be able to blow up the MS-DOS window. But one of the things in CoSy, you'll see it saves the entire environment, which is right now, and this it's 186 kilobytes, and a backup. It goes and makes a backup, and then saves the new thing. But that actually, sorry, I tend to sort of jump around, but you've got a PhD in math, so you've got to be kind of with us. Boy, I've been reading, I was at Northwestern for a dozen years and ended up just hanging around the math department and the computing center that they had. But that brings me, I was going to, let me go and now that I've shown sort of type 0. Well, let me do this first. Everything is stored in a root dictionary, and it's a it's a list of 2-item list. Let me see 2 there. And actually, it's a list of 2 lists. And actually, you were describing this as your database tables. But the first, well, let me do, oh boy, so much to think about what the best path on things are. The first list, but everything that you see is in this list. Let me take the first of those actually. 0, turn it at. This is the same as dnames. This is the names of all of the items. And you can see there's to do in there, there's ref, there's which is actually the contents of this window itself. There's text, which is all of this material. State is all of this material. And actually, because some of them are pretty big, I'm going to just go and take and whoops. Okay, I'll get into, this is where you get to what I used in the Pascal thing, making the not each. I've got each monadic. Let me just go and do it. And this is okay. So this went and grabbed that second column, that second item, and then this is the length of each of them, and you can see, like, there's 87,000 characters in text. So, but let's see. Let me see what the hell you're saying, because I'm going off on my own too much. Oh, yeah. I guess I sort of showed that yeah, Riva's thing is the standard address and length form, but in CoSy, and like I say, I didn't know that Gforth used as quote as its. Let me go and save this in the temporary and in a temporary T0 and return it. I mean, that just returns it as a CoSy string, which has just got a single address. If I do T0 and I shift F6 it, that'll put it, now it's on the stack here. If you can see that at the bottom. And list is the basic. I'm F6ing that, and there it is. Oh my God. Sorry, I'm such a, just the nature of G-Force, yeah, leaves it there. Again, in getting back to what the structure of the header is, and the types, I'm realizing a lot of things that real fundamental documentation things. But the second item is count, and this is where K and CoSy depart from traditional APLs, because in traditional APL, what you'd have is essentially, well, it'd be, I'll write it as row. That in the APL, that's the Greek letter rho, but that's essentially the dimension or rank. And then you'll have, that would be that first cell. And then you have n cells, like for two-dimensional, you'd have M and N. You can find actually all of this definitely on the dialogue or J. There's on types. And this is where, it's sort of the sort of thing they should think, oh, types. Well, let me go and let me show you one of the most important things. This is perhaps a good, here's where I was looking up that T delta. But the most fundamental thing up anything, any phrase you write in here. I'm going to go and do this. Matter of fact, let's see what we get with this. There is a list. This is the thing. All of these things that are in the R dictionary, the root dictionary. And one of the things is realize that every time I execute something, that entire 186K, and actually on my private one, it's over a quarter, getting bigger than that. That is actually being turned into a linear file and stored to the file every time you right before you execute anything, or right after you put down a timestamp. But I have, script 0. Whoops. Words. Well, there's a list in any case. Oh, here it is. This is all of the list of all of the source files, and you'll see actually it's a list named. Where was I just reading it? Where did I just execute? Yeah, here. This is in the R directory. R. I'm going to go and sys v fetch. That whoops, v fetch. That's finding the God, I don't know what this is why it just did a save before I executed that line, which is why, let me see that everything's back to normal. Yeah. I haven't, I write things down that are screwed up all the time, so I'm not sure exactly what happened. Oh, I was executing this. In any case, this is all the source files, and what where's question mark? Where's yeah, type. I was going to go and do this. Question mark goes through and finds all of the instances where of the word type. And I need to sort this out and find, there should be a list of them somewhere. But bottom line is, and actually the names, a cell is a tremendous amount of space to use for that. It really is much more than is necessary. But the names, the most fundamental thing is that type 0 is a list of lists, essentially a list of pointers. So that, for instance, actually I have a word, well, I have type fetch. I know, let me go and see the occurrences of that. But it just searched all of the files listed there. So you can see that type fetch. Oh, that's a special. Oh, here, it's actually just, yeah, type fetch is just a alias for fetch. Not surprisingly, this dictionary is whoops. I think I have a fetch. Yeah, I have a fetch. Well, I'm going to just type fetch. I'm going to just use turn it into why did that not work? Why did that not work? What did I do? Oh. Yeah, that's a good example, I think, where I just, where was I doing what I did? I think I just did something dumb. I sort of remember R, TYPE 0, type fetch, I. Why is it not liking that? Let me just execute it in raw APL. I did get the word right, didn't I? Or is it type fetch? Let me see maybe it's a capital. Oh, it's capital. That's why. Oh, no wonder it's screwed up. R type fetch. Whoops, type fetch. And then let me turn it into a CoSy object so that it prints right. It's type 0 because R is a list, and actually if I go and I look at it, the first cell is 0, and it's a list of 2 lists, and it's got 3 references to it, and it's 20 bits. I think that this piece is not terribly useful. But this is the address of the first item. This is the address of the second item. If I was thinking more I could go and so these are themselves lists. That first one is what you get when you get R0 at. That's the list of names. And that, of course, is a list actually of strings. And actually, they're a symbol type, which I haven't elaborated. I actually, Gordon Kronberg, who runs Dialogue, actually asked a really good question at the Minnowbrook conference some years ago. And if you dig into some of the Minnowbrook conferences, you'll see, I think he asked the most interesting question is, what is a symbol or a token other than a string? And actually, I'm thinking, and essentially the answer is it's a string that's got no spaces in it. But I'm finding that having it as a separate type is perhaps more of a hassle than it's worth. But most fundamentally, I mean, figuring out a good taxonomy or a good numbering system, whatever, for types is actually, I think, it's something that I'm not settled on. In some ways, I sort of borrowed what APLs use, which sort of is how many bits is the thing, or how many bytes is the thing. That's why for the type for string is 1 or 1 bytes. For integers, it's 4. For floats, let me do a float. And got to turn that into a float list, because and these are some things that can be enormously simplified with a little bit of work in CoSy, the notation, having it so they automatically go and are produced as a. I find I'm touching the screen here to point at things. Too much good. But let me do. Let me dump this floating point number. And that's Shift F6 again. Say it's A, it's 10, because it's 10 bytes. There's just a count of 1 and nothing referencing it. And it's 50, I think I got 50 bits. This is, I think, pretty useless. But here's the floating point. I don't know how long the floating point thing goes. But in any case, there's a sequence of floating point numbers after it. So one of the things, and actually I got the impression looking at your stuff that, you can see when I look over and see because that lists of lists are the generic type. R, for instance, is a list of arbitrary items. If I go, and actually something that I talked about a little bit, but I relatively recently just made rather simple thing. That makes an arbitrary list. Okay, there's a string. Here's a floating point. That's Shift F11 puts down a timestamp, and timestamps are virtually unique when they're to the second, and depending on what you need, they're the best index for anything. Trying to think, do an integer. Oops, let me do a. Oops. This actually, what tick does, I have a specified nil value, a nothing value, which is very useful to have. and actually the opening paren tick goes and puts a nil on the stack, and closed paren tick goes, and then of course it executes everything in between, and this closed paren goes and turns everything up to that point into a list. So actually I'm going to save that, so look at it, T0, but there is a general list. I mean, the first item, well, I see now, I looked at, I see I have TYPE, fetch, and then up to turn it into an APL thing. That's the whole list itself is a general list of items. T0, I also got a lot of, this is the shorthand for doing the underbar I, but I go and check that. It's a string, its type is 1. Let me, as a matter of fact, go and show again the value. I tick that. And this is something where fourth is more brilliant than APL. In the tick goes and returns the address. In a sense, it turns a verb into a noun, and it takes it as a noun. But you can do this each M on it. So this is the type of each of these items in here. The first one is a string. The second one is a floating point. The third one is a integer. And those really are the major types. But one of the things is when you go and make a generic word, the first thing it looks at is type to know what it's supposed to do. Like for instance, well, actually, row. I'm trying to think of a word that. Well, actually, most of these there are lots of words that look at the type as the first thing that determines what they do. So that allows you to have well, all the different types. But the most generic one is you can instantaneously just zero goes and says, okay, this is a list of other items of mix. This is a mixed list. Oh, okay. Right. Yeah. Oh, yeah. Well, I wish I knew. They call them tuples. Okay. Um, I like the word lists. I mean, in APL, it'd be called vectors. The old word in APL was vectors. And one of the things is anybody that knew a little bit of math would think, oh, you mean a pointer in 3 dimensions, Whereas a vector in APL just meant a list. And Arthur Whitney really is the one who started just using lists. And I like that as ordered list. But yes, in a sense, the tuple is the most general type. Yeah, and generic operating overloading, yes. You could see in, well, let me, for instance, um, I like having another aspect of Riva that I really liked, other than having, there really is a real importance to having a symmetric delimiter, comment delimiter, versus and having pairs. Those are some very fundamental sort of aspects of things. But uppercase F is not a floating greater than, it's file read. So here's the whole main. This is like Sam described, the main file. And yeah, that's returned as an object. You could look through there and you'd find some generic words. Well, anything obviously that's handling multiple types. And actually, there's a lot of that genericity that I just haven't implemented because, again, it sort of gets into the standard thing. Actually, the thing that's most outstanding is I really need to get multiple windows, so I'm not just stuck in this little thing here. I'm so tantalizingly close to it. It's perturbing. But yeah, you see that that file is 61,000. Let's see what your notes are. Yeah, I sort of, in Haskell is big. I consider Python. I mean, that's the big language today, and it's 25 years old, and it sort of beat everything. But okay, tuple is a member of a Cartesian product, while a list is like a sequence. A sequence is a function from some contiguous to a set. Okay. You see, now in APLs they started off being purely rectangular arrays of well, essentially the limitation on the number of dimensions was just practical. But I remember this goes way back, and back when I was learning APL, I also I learned APL partly because I could write a definitional Fourier transform in a line, and I needed to, because I didn't have time to do anything else. But one of the things is looking at Cooley-Tukey, I realized that in APL, you could go and do a very elegant Fourier transform, fast Fourier transform, by essentially taking the number of elements, and 2 to the n is very, very nice to use. And let's say you have a 1024, list, wavelength, waveform, whatever, sample. You express that as a 2 by 2 by 2 by 2 by 2 blah blah blah, n-dimensional array, and then all of the collapsings that are done in Cooley-Tukey are just reductions across those dimensions. And I thought I noticed some that in a sense Cooley-Tukey missed, but a Cartesian product. Actually, let me. Also, actually, here's another one of the, yeah, a couple of things that I noticed in 10 needs to be an integer iota. There's also just underbar iota. But this was one of the things, the first instruction that made me think, what the hell is this about? This APL about? What has it got an instruction like that? But iota, I think of as being an address space, and you're describing it as a function for some contiguous. Well, you starting off 0, 1, 2. Well, that's exactly what iota. It's an index, to go and do. I'm trying to think. That makes actually a second absolutely separate copy. ... It's like dupe, except it actually deals with the function counting. It makes an independent copy. I'm trying to think. Oh, okay, let me do this. Now first, actually, before let me go back here. I'm gonna wipe out my previous T0. I only have a few of these. I've never factored out the 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 actual setting of variables. Again, I sort of thought of things in terms of vision. It's sort of like the things that are implementing the fundamentals versus fleshing out and making nice. Things that are, if you will, more standard. But okay, so I've got T0 here. And if I go 10, and I'm just going to use I, and then times I, times I is actually the upper level sort of a thing. You notice that it did, it just applied that across all of them. And this is and actually the modulo programming in modulo indexing in APL. Let me make this an integer index, an integer list. There, it repeated the elements here to match. So you see, that's one of those generalizations, and actually that's something that I find really nice. But what I really wanted to do back here with the dupe, well, this is going to go and do the multiplication pairwise each, and you can see actually this is the thing where plus is going to go and do the sums, but let me do the times. But let me, instead of going and doing it like that, check that. So, okay, and then hand that to each right, okay? Whoa, why did that fail? Oh, I know why. It's something incomplete. I understand why. Oh, but trying to think. I wish I could give you right off the top of my head essentially a Cartesian product. Because in a sense, why? Oh, I think I know. I think I need to make this an actual function. At least this should. Oh, good to initiate. There you got a Cartesian product. Okay. Yeah, actually, I think the traditional APL, that was the name. I don't know whether that's still used or not, but yeah. And actually, that actually does bring up a real point that essentially a lot of these functions operate on, they go out to lists. There's some the function C goes and shows the internals. I think that's what I named the stupid thing. I'm Shift F6ing because this is raw. Okay, it's deferred word, so that doesn't say so much. This is a word. Oh, yeah. This actually would generalize things, but essentially, apply goes and applies everything out to all the leaves of a list. And the thing is that these things like you'll see homogeneous lists of integers or lists of floats or lists of characters. Um, that's what you're seeing. Actually, let me turn this into a list. You'll see whoops, 1, 2, 3, 10, 24. Okay. You'll see each of the types. Oh, one other thing that I should add here is a general list. Um, no, I'm not going to be so daring as to, well, I am going to be so daring. You see how quick it, and I'm not sure whether this notation, what that'll do when I just give it an empty. I mean, nothing. Oh, it was happy. It just turned it as a general list. Okay, as an empty list. So do this. Yeah, the first item is of type 0, is a list itself, and P0 um, actually one of the things equivalent to 0 at is disclose, um, and so that's the first item. And actually, that makes it with disclose and all the rest. Actually, you sort of have the Lisp, first and rest sort of a thing. Arthur was quite. Arthur knows so much more. I mean, I first programmed a computer in 1963, and I never really took any. I don't know anything. I don't know this computer, science stuff that came. I gotta say, I mean, obviously I do know some, but yeah. So that the first item here is an empty list, a general list. Um, but actually, this is turned into a good demo in a sort, because this is a good illustration. I mean, this is an excellent illustration of the different types that exist, and what their type numbers are. And I'm not super satisfied with that. With this, there also is another type, like I say, symbols, which is very convenient. The writing of it with a backtick is why I did that. See, I'm as likely to go, and locking up all of this stuff. Well, you see, these are my notes from the talk. Actually, this is but this is something my universal disclaimer. CoSy follows an irritation driven development agenda, particularly with respect to bugs, because uh, it's now a higher priority with other people getting into it. But I'll write things down that bomb, and what matters to me is that I can get back to where I was quickly. And that, yeah, just simply not been the top priority with me locking up all these things. Furthermore, it's not that trivial. Where was my, oh, I'm still, here we go. Why did, Well, I gotta say, I think I actually have a bug there. Because that, I don't see why that wouldn't work. I'm wondering whether it has something to do with this because actually it's something that is very, very common for all of my accounts generally have. Um, huh, somehow or other, oh, this might be very telling because it appears to have something to do with my having embedded this empty empty general. Let me stick something in here. Yep, yep. Okay. So I learned there's some bug there with the I don't got to figure that out. But anyway, let's see where I. Yeah. Okay. So that's why you're in fourth. You don't know any better. Um, yeah. Uh, let's see, Cartesian, I think they call this heterogeneous. Yeah, a homo. The thing is that, yeah, with respect to CoSy, when I refer to a leaf, that actually is getting out to a homogeneous list, at which point there are the algorithms, the specific algorithms that operate on integers or operate on floats or operate on characters. Um, well, obviously, I think by uh, let me see. Let me go and take a look at something like. Well, there are a whole mess of the. I wanted to come down here just for simplicity. Um, I haven't generalized most of the things, but the thing is, the type is what allows you to go and do the branch on whatever the thing is. Let me just go and here essentially I give any the what plus plus or what question mark does is it goes through those files and it splits them on every truly blank line. So I still, because I don't have multiple windows, actually use this JEdit, which is way too small, and I wonder whether that'll go and expand easily. I don't think it will. I gotta do some other. But one of the things about it, oh, I think I know what I can do here to go and where did I read in? I read in. Oh, this is current. Oh, here, this is sitting around. This is actually my math. I have a math script that's got some basic math things, and I was going to add the Pascal triangle to it, but some randoms and so forth. But that's the what I wanted to show you. If I do, what did I go and back to my drawing it as T0. Well, this is I have a word. Well, things like line feed, okay, which is the basic break. Yeah, you can't see that. Um, but let me split this. If I go and there's T0, there's that, and what's the length of that? It's 3,700 characters. Okay, if I split that on, let me, I have, and this is an old vector to matrix, is old APL term that I use. But now, actually, the only real difference you can see is that it's got a paren at the front. But one of the things is that split it on all the line feeds. So now it's split it into 159 rows. Though actually, one of the things I think that yeah, it's one of the things is you can see that there's this commonality to the ideas and so forth which came from matrix algebra, and for that matter, I mean again with multiple dimensions, it's any array tensors or whatever, or Christoffel symbols. Do you know Christoffel symbols? Um, but anyway, it's 120 lines, and if I go and do that, actually, because I use it so commonly, I've recently made row each. It's essentially the length of each. But what you see, these are totally blank lines. Question mark goes and splits on all totally blank lines. So it actually, I guess, is the same thing as, well, let me do it this way. Oh, because, yeah, something that really, uh, reverse Polish has got its downside, but the fact that you can split things apart as easily as this, this is another one take, a lot of common words where I use things off the spec. I just have it says got underline I built in there, but oh, you're never going to be able to see this either, except you see that, let me just do row. That's two. It, let me do let me do something that's a little more visible. Uh, so I could do, or actually more fun is, uh, but in any case, getting back here to splitting T0, still it's not that clear, but let's see what row is. Yeah, there are only 39 sections. So let me do on each one of these. Oh, I know. I remember what I was going to do first. In any case, if you look at the word con, which is a very, very common thing that I use, you'll see this word con. It'll go and look at these strings and return any that contain any particular phrase. So what question mark does is it essentially splits on pairs of line feeds on purely totally empty things. So if you want something to not split, you just add at least a blank on the line, and then it'll be lumped together. And that's why when I looked at now here's the stupid line around. Just let me do plus I. When it retrieved that, none of these have blank lines, so it retrieves the whole group. So you can group things so you get, have there's stuff, but you'll, you'll see that's. Did you go to Caltech? Um, yeah, Jerry had it. I think it's Slava Pestov who created Language Factor, which if you're not familiar with, you should check out Factor. And as a matter of fact, if you search on CoSy, you'll see one of my newsletters. I really spent a bit of time looking at whether I should continue with CoSy or just go to Factor. But I think he, in a sense, suffers from too much comp sci, because it's got like a kitchen sink, full of every notion of computer science, where you can see CoSy, hey, everything is just a list, or if you want to call, well, okay, call them. Oh, yeah, Christopher, I read um, um, Yilmaz, Hussein Yilmaz, relativity and modern physics, and he gets into Christoffel symbols on there as sort of like the derivative of a tensor or something like that, which is not itself a tensor. In any case, yeah, there's no question. Differential geometry, and I learned most of my math sitting in on math courses and just hanging around. I was living with Bob Williams, the professor there. Now he's at Institute for Advanced Study. He's hanging around, actually, his woman friend, Karen Uhlenbeck, is the reason why Institute for Advanced Studies have him around. He's retired, but he had a pretty much empty house, so I and some other grad students were there and ended up hanging around the math department parties, and when people like Christopher Zeman or Stephen Smale or whatever would visit, I met some of them, but and I'd sit in on the grad courses in math, and that's why I got kicked out of the PhD program in psychology. Yeah. Yeah, if I'd lived a really decent life and not spent 5 years in high school, and then had good grades and all of that, I might have, ended up at Caltech in 1962 taking freshman physics. But back in '96, I somehow thought you were younger than that. Simplicity is good. God, you trigger. Why don't you give me these trigger warnings? Well, how did that get so? Oh, I've been trying to blow things up, and this is what got blown up. And not this page. Why not this page? Yeah, I have at this. This is the. Click the top of CoSy. You get technical skill is the mastery of complexity, while creativity is the mastery of simplicity. And Zeman was one of the guys. Actually, I have a note. Zeman. I always refer to as the greatest mathematician who ever bought me lunch. But and then another time, and this is one I take to heart. Another time when I was concerned with getting credit for some idea I had, Ken Iverson said, "Arthur, if it's a really good idea, you're going to have to shove it down people's throats." And you go and you look at something, the history of something like either APL or Forth, you know the truth of that. And Alan Perlis, this is one of the things that's very central in terms of the structure of CoSy. Is there's one data structure, just lists. Better to have 100 functions, 100 verbs, operating on one data structure, one type, if you will, then 10 functions on 10 data structures. But then this one I've just only recently got, which is in his 1970. Oh, I didn't mean to flick that, but in any case, it's just something he says sort of offhand, but I've gone to some lengths to simplify. And that is pretty, yeah, that's for sure. No, I was in psychophysics. If you go and you look or you even read the newsletter I put out, I had an older retarded brother who died just a couple of years ago, and I didn't when I after spending about 5 years getting through high school, and I did ace the physics SAT. I didn't know why the hell I wanted to go to college and so forth, but then after some crap jobs, rolling dough at Sara Lee and things like that, I realized that, well, my brother's brain doesn't work right. So how the hell do they work? And so I just, I had a reason to go and learn things. But the thing is that I had the notion that psychology departments were where you learned that sort of stuff. But I really didn't learn much math until by the time I was in grad school working on a PDP-8 in the psychophysics lab. I realized nothing other than mathematical explanations made sense to me. So yeah, um, yeah, but that's I was in psychophysics and visual perception, and one of the things that sort of turned me off, but also sort of gave what the nature of the department was, is there was this classic experiment at Bell Labs by Heckschler and Perrin. I've got dogs that I've got to let out here. Just 1 second. Come on, dogs. But anyway, Heckschler and Perrin did an experiment determining that the minimal threshold for humans seeing a blink of light was about 6 photons, which end up being Poisson distributed. And all of this was essentially taught in psychophysics. But my immediate thought was, okay, why is it a Poisson? What is a Poisson? And I actually got crap from the head of the department for sitting in on the undergraduate, math, statistics and probability course. And actually, I'd actually not, well, my first freshman year, I flunked out everything before I got a purpose, including calc and so forth. So I actually read Thomas, major calc, textbook. I don't know whether, but I really didn't do any until I actually was in the C-level probability and stat course, and so my background is extremely idiosyncratic. Yeah, math is deep. Yeah, anyway. um, I don't know, yeah, maybe it'd be good. I actually am enjoying this, but do you think this has been, I mean, it certainly has been now a useful exchange in many ways. Stuart, for intro calc. Oh, Apostle is, yeah. I mean that name I recognize. Oh, you. I don't think I completed my statement, but that I think this has been, yeah, this has been when it got going. Although it clearly brings up lots of issues to be you know ironed out. Yeah, it's been a pretty substantial amount of time. And I think that one of the things is it takes a certain sort of head to follow the ricocheting path that this has. Um, okay, but yeah, I think this is not bad. Sort of a thing to think about. And I may post some things, but this issue, a cell 32 bits is too much space for the types, and they need to be a reference to the vocabulary that deals with them in one way or another. It has to tell, but that goes and allows you to have all of these mixed types, and then again, rather than having uh, M and N or M N P Q whatever dimensions. There's actually a if you look up the Turing awards, if you look up talks, Ken Iverson, Ken Iverson got his Turing, I think, because John Bacchus had gotten one like the year or two before and talked about Ken's overcoming the von Neumann bottleneck. But one of the things that Bacchus pointed out was that really you could go and store and work with arrays as lists of lists rather than these rectangular dimensions. And that's what Arthur did. And when I got into K, my main question, and if you go and search back in old parts of CoSy, you'll see my fundamental question is, does first axis suffice? And essentially you reach into deeper axes using using these variants of each that you see, like each monadic and each right that I used. And those differentiations are really from K. But in many ways, this is simpler sort of a thing. So anyway, David, it's great chatting with someone who can follow my meanderings. And this is definitely a step towards getting things more organized. Thanks. I realize much better. I got to have immediately available. Here's the list of types, for instance. But anyway, open questions. But you see, give me some. If you go and try to get it running, let me know what happens. Okay, because man, if the two of us, working on a common project, enormous amount more power than working on some isolated. Thanks. Over, and now I'll try to figure out how to go out. Maybe I just shut the bloody window. That didn't do it. I think I got some. That didn't do it. That goes recursive. Stop. You're screen sharing and present to everyone. Stop. Oh. Now what does that do? Stop broadcast.